This is a question on transformer. It's not a difficult question, but it's pretty tedious. And there's a lot of data given to us. We have to make sense of it. Our objective is to find a combination or connection rather of how we can connect all these things together so that the lamp lights at normal brightness. And what do we mean by lighting at normal brightness? It means that the voltage across this lamp, we are aiming for it to be over here 6 volts. When you apply 6 volts, the lamp will function at its power rating, and that's the normal brightness. So we are aiming to have output secondary voltage from the transformer to be 6 volts. That's our aim. And let's solve this part by part. The answer to this question is D, and I will run through all 4 options. So option A, let's say for option which is the wrong option. We'll see why is it wrong. So we want the coil to be attached to the, or rather we want P to be attached to the AC generator. So over here, and we want Q and R to be connected. So Q is here, R is here, and S over here is connected to the lamp. This is how the connection looks like as depicted by option A. Therefore, this is the first input voltage. 50 turns to 1000 turns, we're looking at 20 times greater number of turns. This is a step-up generator where the voltage will increase by 20 times, like what the number of turns has increased by. And then going on to coil R, 50 turns to 100 turns, we're looking at a 10 times increase, and therefore this is another step-up transformer. Therefore, if we do the sum, when we have an input of 12 volts and we step up by 20, so we multiply by 20, then we further step it up again by 10, multiply by 10. So 240 volts will be the voltage across coil Q. 240 volts applied to here, multiplied by 10, will get us 2400 volts. The lamp will burn because it's meant for 6 volts, not 2400 volts. Okay. Now for option B, this is the connection. So the input voltage is again a 12 volts AC supply, so 12 volts here, and 50 to 1000 turns again multiplied by 20. So this is a step-up generator. Then we go on to coil S. 500 turns to 50 turns is 10 times lesser, so it's a step-down transformer. And let's just do the sum. 12 volts step up by 20 times, so 12 times 20, that is 240 volts. 240 volts applied to here, step down by 10 times, so divided by 10, so you get 24 volts. The bulb will also burn again because it's meant for 6 volts, not 24 volts. A bit better than option A, but still it will burn and you will destroy the bulb. And we go on to option C. This is the connection. So we will first step up the voltage from 12 volts by 10 times, and then we will step up again by 20 times. So stepping up twice, you should expect to get a very high voltage at the bulb. So 12 volts multiplied by 10, step up by 10 times, that's 120 volts. Step up further by 20, so multiply by further 20, you get back again the same output voltage as option A. You will burn the bulb spectacularly again. So moving on to the last option, which is the answer. This is the connection. So at first we are stepping up the voltage from 12 volts 10 times, and then we will step down from 1000 turns to 50 turns, stepping down the voltage. So 12 times 10 divided by 20 gets us the 6 volts as required. So I hope when we learn transformers, learn about transformers, we will do our part for the world by not burning so many bulbs. We can just calculate first before we connect our transformers.